Hi everyone, this is Mr. Dubrow. Welcome to the first of several videos showcasing or explaining various concepts in AP Physics C, Mechanics, and Electricity and Magnetism. So this first video is going to focus on the vector dot product and the cross product. And these are two very important concepts that you're going to need for the rest of the course, and we will see many different examples throughout of the dot product and the cross product. So what I'm going to do is I'm going to show you these through example problems. So this first one is number 95 from chapter 1, and we're given two vectors. Vector A is 5 I hat minus 6.5 j hat. Remember, I hat and j hat are the unit vectors in the x and y directions, and we're given vector B is negative 3.5 I hat plus 7 j hat, and we're also told that vector C is in the same xy plane as A and B, and C is perpendicular to A. So from this, we're asked to find the components of C. So we're talking about Cx and Cy, and sometimes we put them in little brackets like this. Okay, and we're also told that the dot product of C and B is 15. Alright, now first a little bit of review of what the dot product actually is. So the dot product is what we call the scalar product. And basically what it does is it tells you how much of one vector is in the same direction as a second vector. Sometimes we call this the projection of one vector onto another. So for example, if I had vector P and vector Q, then the dot product would simply be the amount of P that lies in the same direction as Q. And so algebraically, what we would say is that P dot Q is equal to the magnitude of P times the magnitude of Q times the cosine of the angle between them. Now, the right side of this is pretty easy. The magnitude of P and Q we can find because that's just from the hypotenuse, if you will. The left side, what we're doing is we're basically adding the components. Whoops. So we've multiplied the P and QX components, the P and QY components, and the P and QZ components, and all of that added up will give us the left side of this equation. Okay, so we can use this to solve a problem, because if we know that C dot B is 15, then we can say that Cx times Bx plus Cy times By is equal to 15. And we're given that Bx is negative 3.5 and By is plus 7.0. So this means negative 3.5 Cx plus 7.0 Cy is equal to 15. So here's an equation with two unknowns, Cx and Cy. And then we can get a second equation from the fact that C is perpendicular to A. Now, because the dot product is the magnitude of the two vectors times the cosine of the angle, we know that if P is perpendicular to Q, then the cosine of that angle is going to be 0, because the cosine of 90 degrees is 0. And so what that means is that if P is perpendicular to Q, then the dot product is equal to 0. And this is a very important property of the dot product. So now going back to what we're given, we know that C is perpendicular to A. So that means that C dot A equals 0. And so we have CX AX plus CY AY equals 0. And we have the components of A as plus 5 and negative 6.5. So that allows us to write a second equation, 5CX minus 6.5 CY equals 0. So here's the second equation, and now we have two equations and two unknowns, and at this point I would just do a little bit of algebra, and I will find CX is about equal to 8.0 and CY is about equal to 6.1. Okay, so that's a short review of the dot product. The cross product is very similar. So this is number 96. In 96, we're given that vector A has a magnitude of 3 and vector B has a magnitude also of 3. And we're given that the cross product of A and B is equal to 2I minus 5 k hat. And what we want is the angle between them. So the first thing to understand is that the cross product gives us a very different thing than the dot product. First of all, the cross product is known as the vector product, because what we do is we take two vectors and do an operation but get out a vector as our answer. Remember that for the dot product we got a number. And so now we can look at our definition of the cross product. The magnitude of A cross B is equal to the magnitude of A times the magnitude of B times the sine of the angle between them. And basically what this says is that C is perpendicular to the plane containing both A and B. And this is going to be important later on when we do things such as torque. In electricity and magnetism, we'll need this when we do magnetic forces. So this is a very important concept. And so there's two ways to do this. The way that we originally found 2I minus 5k is to actually set up a matrix with I hat, j hat, k hat, and to put the components of A and B. So we have AX, AY, and AZ, and then BX, BY, and BZ. And to actually compute the cross product, we would think about determinants. So remember, we would kind of imaginary cross out that row and take the determinant of this, and that would all be times I hat. So that's AY BZ minus AZ BY. Then the J hat would be something similar, where we crossed out the middle column in the top row, then we do minus J hat AX BZ minus AZ BX, and then finally we would do the same thing for K hat, and we would do AX BY minus AY BX. Now this is a little bit too much work for our problem, and the reason for this is that we already know enough to solve it without having to do this. So you could think of this as just a review of how we do the cross product. So what we can do is actually calculate the value of A cross B. So the magnitude of that would actually be the square root of 2 squared plus 5 squared. And that comes from what A cross B is, 2I minus 5k. And so the length of that would be like a hypotenuse. Okay, that's going to be equal to the length of A, which is 3, times the length of B, which is 3, times the sine of the angle between them. And so what we get is that the sine of the angle is the square root of 29 over 9. And so that means that the angle is about 36.8 degrees. And that's our final answer. Okay, so I hope that this was helpful to you in learning a little bit more about the dot and cross products. And once again, you'll be using these throughout the course.